Hopefully the slides
Yes.
came up.
Yes, it came up. We can
All
see
right.
them.
So what I was hoping to get through today is just talking about how your watershed works and providing information that helps you do that. I wanted to have some discussion about some of the factors that affect water quality in your watershed. And then I was hoping today to get to actually doing a quick demo on Ptm App Web. Again, I think what we'll do is we'll honor that hard stop of on the hour. And if we can't get to that, then we'll just move it to the next time. Again, remember, I'm going to be doing some polls today. One of the things we're going to be asking about is your GIS capability in your office, because that helps us understand those capabilities and how or whether you can create some of the various products. So that's going to be one of the polls today. In terms of those polls, I did check this out. You can actually text your responses in too, if that works better for you. So if you have your phone, you can go to, actually I better activate those now that I think about it. So you can actually text in if you want. I thought that some of you may have a single screen and that may help you do that as well. So if you want to text in, you just text in Mark, DEUTSCHM 866, and then to the number 22333, and you'll be able to join. This will come up again on the poll itself. So, all right. One of the things that I've been working on, that we've been working on the Institute, is just what is the process going from start to finish to develop a water quality strategy. This is the flow chart that I put in the folder that you can download and look at. I would appreciate your comments on this. The idea here is that we have a step-by-step process that shows how you go from essentially where we're at today, which is how do I understand my watershed, all the way through developing a water quality strategy, ultimately implementing that strategy, and then tracking progress as you implement. So we're going to start at the start button, and we're going to stop through the workshops at the stop button. Again, right now, we're just in the very first step, is understanding your watershed. Last week, we talked a little bit about what areas are we going to use as examples. Certainly, if you have feedback, you want to use additional areas or different areas, let me know. To a certain extent, I can accommodate that. I'll try to mix these up as we go so that I don't always use the same areas, because I know we have coordinators from multiple watersheds and from different counties. But Greg sent me some information about some of the water quality challenges that you're facing. So the case studies that I anticipate using for the workshop are in the Wild Rice River, the Cheyenne River, Maple River, and then Park River and Homie Dam. We're going to start mostly with the Wild Rice River because I've spent time on a method to help you identify where to begin work in that watershed, and I want to illustrate that. And that took a fair bit of time for me to develop. So we're going to start with Wild Rice, and we're also going to include some early work on examples from Homie Dam and the Park River, but we'll try to include other areas that we demonstrate, and also the techniques and the methods that we're going to show you should be applicable to any of these watersheds for that matter. I did want to share like the first takeaway from one of the polls that we talked about last week. One of the things we asked you is like, well, what one single thing do you want to learn from the workshop? And I thought it would be worth sharing that feedback with you. I think kind of one of the common themes was just what are the steps in doing my water quality work? How do I identify areas where I should begin work? How do I target areas for prioritization, and how do I use Ptm App to do that? So that's why I put the blue winner sticker on here. Those three bottom items really relate to that. How to identify areas where I should start work? How do I identify where the problem areas are? And then ultimately, how do I use Ptm App to develop a strategy? Again, I'm going to show you how to use Ptm App, but within the context of addressing water quality concerns in your watershed. So I wanted to do the first poll at this point, which is I want to get a sense of what your capability is for doing GIS work within your organization. It doesn't, you know, basically what I'm asking here is some sense of your GIS capability. It doesn't necessarily mean that you have to have all that capability, but that someone that you can get access to has that capability for helping you do your work. So the poll should be activated. It should be live. Looks like we already got a couple of responses. I'm going to try to pull it up on the screen here. Maybe. Starting to look like it's one of those days today. So the reason again that I'm asking this, and you guys should see the poll live on your screen right now. If you can, give me a thumbs up. But the reason I'm asking this is because these relate to some of the products that we're going to show you. And so I want to find out, you know, your ability essentially to create these products yourselves and how much reliance otherwise would be needed on the web to create these products.
So when I click on it, Mark, all it does is turn to a 1. Does 1 mean yes or?
It seems to be.
It's defaulted to a 0, and when I click on it, it just kicks up a 1. So
1 should be a yes, I would imagine. Let me take a look here. So you can respond multiple times, is the way I have this set up. You can only select each option once, and you can respond up to 7 times. So basically click on, you know, if you have no capability, you would enter a 1, I think, by A. And then, so essentially you would respond in the affirmative for every time, for every capability that you have. Not working that way?
Yes, it is.
Okay. So you should be able to respond 7 times. Basically, my idea was that for every single one of those, you should, if you can do that in your office, go ahead and you know, make that selection essentially. That's what I'm looking for. Does it seem to be working that way or no? Yeah, okay, cool. So I'm just going to leave that live and then we'll just go ahead and continue on. And then we'll come back to that in just a bit. And again, the reason I'm asking these questions is we're going to show you how to create a source assessment map, how to use tools to describe your watershed. And so it helps me understand whether you want to do those in your office, you know, on your desktop or use the web in Ptm App. So one of the very first steps in the watershed process is physically just describing your watershed. The way that I look at that is just like, where am I going to do my work? What is the actual watershed boundary? One of the things that I want to point out is that going back to the earlier question about, you know, what are your GIS capabilities? Most of you probably know that there's a wealth of data on the GIS hub in North Dakota, including the watershed boundaries that you can download and use on your desktop. You can also, those also are available on the web, which I'll show you later today as well. But this is a great source of information. Another thing in terms of describing your watershed is just where are the lakes, the rivers, the stream reaches, the reservoirs in my watershed. I know that that sounds fairly trivial, but often it seems like we maybe miss a lake or a reservoir when we start talking to your board members or others. So, you know, having a map that shows all of the lakes and rivers and reservoirs and stream reaches is useful. Grit and I have been using a data set that I developed some years ago that we can make available to you, but you can also get that information from the GIS portal. And then lastly, when you're thinking about describing your watershed, most of you are authorized only to work in a small portion of that watershed or some subset of the watershed, typically your county boundary. So, you know, in terms of describing the physical features of your watershed, this is the kind of information that you want to use to describe where's my project, where's my watershed area, and then where's my county, because ultimately we're going to have to prioritize water bodies that you're going to work in by your county, because that's where you're authorized to work. So this is an example that I put up into the shared folder that Grid created for me for describing the watershed. This is one way that you can describe the watershed. What I'm showing you here are the various stream reaches and data from the North Dakota State Department of Health website that shows the impairment status of those stream reaches, whether those reaches are having challenges because of too much sediment or too much nutrient, whatever the reason for the cause is, and then what's affected. So this is one simple way that you can use to describe your watershed. Presumably those areas that are impaired or that are having problems, those are areas where you potentially might want to start your work. If you guys have any questions as I'm going along, please, you know, pause. Again, I did put this in the folder so you could download it and look at it at full scale. Okay, let's go back to the poll real quick. So looks like most of you have the capability to do simple maps like Grit has generated. I can do them, so I'm proud of that. I had to teach myself and it took me a while, but mostly what we're talking about here is the ability to find data, download that data, and then make maps showing that information and sometimes joining tables as well. So, okay.
Mark, we could not see your poll.
Oh, it didn't kick over?
No, it's still showing the slide.
Oh, okay. Well, I don't know why it's doing that. We're just going to keep going with the slides. I have been putting the poll results out there as well. So now you should be looking at a slide on the screen that shows the hydrology boundaries for North Dakota. Is that correct? If it is, maybe you can give me a thumbs up. No? Yeah, okay, cool. One of the sources of hydrology boundaries for North Dakota is the Water Commission website. So this is an interactive map that shows you where you can get information about hydrologic boundaries. I have the URL on the bottom part here of the graphic of the slide. And then the location for water quality data, I want to talk a little bit about that. That impairment map that I showed you that describes what stream reaches or lakes are having water quality challenges and the causes, whether it's too much sediment or nutrients, you can get from this particular website. I don't know that you guys know this exists. This is a viewer that Department of Environmental Quality has for water quality data. And so the locations that I showed you on that map, you can actually download from here. So you can go in and zoom and get water quality information from these locations. And we're going to use real water quality information monitoring data to help us identify in the next session where the problems are in our watershed. We've actually developed a little bit of a structure for you to use this information to identify priority areas for beginning your work in your watersheds. So my next poll that I want to do is just to get some sense of how much you love statistics. So that poll should be live right now. And hopefully you can see it.
Okay.
Can you see it on the screen, Grit? Grit, can you see it on the screen?
I cannot, no, it's a slide still, not your poll.
Why doesn't it switch over then? So basically what I'd like to do is get some sense of your water quality prowess, your statistical analysis.
That's good.
I'm not quite sure why it's not doing that, Grit. Did it last week. Of course, you know what? It wasn't Zoom.
Yeah.
Let me see if I can try something. How about now?
Yes, it's
Okay.
showing.
Great. So some of the techniques that Grit and I have developed that we'll go over in the next workshop to identify problem areas from a water quality perspective are based on some simple analysis or some analysis of the existing water quality information. So again, by participating in the poll here, you're giving us some sense of how comfortable you are to downloading water quality information, manipulating it, and doing some of the simple descriptive statistics that we'll show you next week. Again, this poll is set up just like the last one. You can answer 7 times. And the idea is that if you have the capability for that particular letter response, to go ahead and enter that. The statistics we're going to use are pretty simple. It's nothing too fancy, so I wouldn't be too concerned about it in the long run. All right, now I got to figure out
How to get back to the slides.
I'm getting there. All right. How's that?
Yeah, you can see the
Okay.
slide. Yep.
So again, you can get the water quality information online from that North Dakota DEQ website. One of the things that's nice about it is you can actually toggle on a given monitoring station and get information about what's the impairment there, how much data they have, and you can do some simple trend analysis. I just wanted to point this out to you because, you know, like say you're interested in how have things been changing through time in terms of nutrient levels on a given stream reach. This is part of the website that I just showed you. You can select a station, and then you can get some of those simple descriptive statistics actually on the web, and you can download the data to your desktop as well. So here I did just a simple graph, simple chart of up on the Forest River at Fordville Dam. What I'm showing you here is a graph of the measured total phosphorus concentrations through time. And this is the kind of statistics that I'm talking about that we're going to do next week. Okay. I'm going to pause at this point. Any questions so far? Comments? Thoughts? Pretty quiet. Okay. Yeah, Grit, did you have something?
No, somebody asked.
I had a
Oh.
question. Are in one of the layers are the county legal drains in a layer? Like the Water Resource District always has drain number 98 and drain 71. And
Yeah,
is
they're
that fairly
on.
well layered?
Yeah, I think they are. I did see, even on the website, when you zoom in on the website on Ptm App Web, it does have drains labeled.
Okay, thank you.
Yep. Okay. Hang on here just a minute. I got too many screens open. Okay, so next thing I want to do is change the discussion a little bit and start talking about what are some of the factors that you think about when it comes to their impact on water quality. And so you guys might be sick of my polls by the time we're done here. Did you get the poll up on the screen?
No. You are, let's see.
Should be up there now. No?
Not yet.
What are you seeing?
Now that your slide again.
Okay, so we're gonna do a little poll if Mark can get it to work. And the poll should be active, so if you're looking on your screen, it should look like this. Did that pop up, Grit?
It pops up, but it shows, now it comes, I think. No responses received yet. Yeah.
So again, this is one of those where you type in. So what I'm looking to do here, hopefully it's working. I don't see any responses coming up, but I haven't really given you any instruction. What I'd like to do is, as you guys think about, what are the things going on in my watershed that actually affect water quality? What changes sediment loads and the amount of nutrients in my stream? What are those factors that, as I'm starting to explore a problem, I think about as being important that affect water quality? And the way this poll works is if you can type that in, again, this is one with a thumbs up and a thumbs down where you can rate what other people are entering. So as you see responses pop on the screen, you can vote them with a thumb up or a thumb down. Are you seeing the actual poll on the screen now?
Yes,
Good.
it shows now 2 entries, tillage and commodity prices.
Other things that affect water quality, what about, how much grazing there is maybe in a watershed, whether there's, too much water that might cause bank erosion, just land use patterns in general, where people live. Maybe storage, is one thing I think about, is how much, a lot of the water quality issues, it seems like sometimes are driven by the amount of runoff. So if you have more storage in your watershed, it tends to kind of slow water down. Again, you should be able to use your thumbs up and thumbs down to rate these then once you see them pop up on the screen. Remember, you can use your little thumb, and if you hit an up, it'll add to that category. Land use is kind of popping around. So I'm going to leave that live then for you guys as we continue on. So what I did, I don't believe I put this up in the folder, but as I was thinking through this, these are some of the factors that I thought about, is just what is the landscape setting. The water quality typically is very different in, say, the Lake Agassiz Plain region than it is from the northern glaciated plains or over in the Missouri Coteau area. So just the kind of the landscape setting, the soils, the type of crops, vegetation, all that stuff has an effect on water quality. And some of the other factors that I wrote down is just what are some of the elevation changes. Poor Matt squinting, and I didn't put this in the folder. I'll put this up in the folder for you, but changes in elevation, the shape of the watershed sometimes affects water quality, land use, where people live, is there some sort of mineral extraction occurring in the watershed? How are the drainage systems connected? Storage is a factor that I think about, because the more storage you have, typically it slows your water down a little bit. It also affects how long it takes water to move through the watershed, which affects water quality. I've seen areas where there's high concentrations of wildlife that can sometimes affect, fecal coliform bacteria levels. If you have a wildlife refuge like Chase National Wildlife Refuge or something like that in there, you can have a fairly dramatic effect. So I will put this in the subfolder for you to take a look at, and if you would do that, I'd appreciate it and give some feedback. But one thing I want to point out is that when we start looking at these factors, we have to look at those. Like what I typically do is I look at the factors from multiple spatial scales. So I start kind of at the higher level, whole project area, whole watershed area, and then I get finer and finer in how I look at the problem. So maybe I move down then to the 10-digit HUC and ask myself, well, how do these factors change as I zoom into the 10-digit HUC level, and then the 12-digit, and all the way down into the field and subfield levels. So not all these factors apply at every given spatial scale, but it's something to think about, how these factors change with spatial scale. And then the other thing that I always think about is, you know, how these factors change through time. So what I'm showing you here, I don't know, you guys probably know this exists since, you know, you're in the soil conservation districts, but the cropscapes, cropland data layer is a good source of historic land use information. What I did here is I just zoomed into Ransom County and I pulled off the data for 1997 and then compared that to 2019. And there's other tools up there where you can look at the land use data. If you talk to the producers, a lot of times they'll tell you that they're not sure this is entirely accurate. You know, this is based on satellite imagery, is my recollection, but you know, this simple example, you can see on the lower right-hand graphic, all of the green that starts popping up. And that green is basically the soybeans. So you can see a shift from, on the left, it's yellow and kind of the bright yellow is sunflower. You know, you're not seeing as much sunflowers in 2019 as you were in 1997. But this gives you a sense of how things are changing on the landscape, which definitely is one of the factors that affects water quality, and that you need to think about how those factors change through time. So here's kind of what I think about when I approach this issue of what are the factors that affect water quality, and I tried to come up with a slick graphic to illustrate this. But when I think about the whole project area, you could kind of, you know, relate that to looking at the problem with your naked eye. And then as you zoom in, or as you get finer and finer in scale, you're bringing more and more focus or magnification to the issue. So look at the factors again at kind of the whole project area scale, and then the 10-digit, 12-digit, and successively finer scales, and then zoom back out. You really kind of have to think about it, you know, about those factors from a very high level, and then they're going to change again as you move into the subfield level or the field level. So I don't know, I always analyze it till you got to kind of look at it from all angles, maybe is the way to put it. The one thing I want to point out when you're looking at changes through time, both in terms of water quality and what some of the factors are that you think might be influencing that water quality, you just have to be careful. You know, I made up this fictitious graph where I related an x-axis, that is the annual sediment load in my river, to, again, I just made up something so it was an obviously spurious correlation, right? It's not real, but number of wild turkeys in my county, I like to hunt. So, you know, obviously there's no relationship between, at least I don't think there is, no cause and effect relationship between the number of wild turkeys in your county and the sediment load in your river. But you just have to be careful when you're looking at those factors about ascribing cause and effect. So there may be other factors going on. Maybe you're seeing those land use changes, but there's other factors also that are changing sediment loads in your river. So you just have to be careful about that. Okay, I'm going to pause here for a minute. Go back to our poll. So here's what we kind of had for the factors. And again, I'm going to post that table that I did up on the website for you, or up on the Google Drive, so you can look at it. But not surprisingly, you know, in agricultural areas, most of us are thinking that the water quality and quantity to a certain extent is driven by tillage and land use and basically general water movement through the watershed. Probably doesn't surprise anyone. Okay, everybody ready for Ptm App Intro? Now I'll see if I can do this. If you did get a Ptm App web account, you can go ahead and pop that up on your screen and sign in. I'm going to pull mine up on the screen. And so we have about 10 minutes left. And if you're having troubles getting into your account, let me know, but did everyone pretty much get in? Everybody in for the most part? Thumbs up? Okay. So we've got about, we can go as long as you want, 10, 15, 20 minutes left at the most since we started late. Does anyone have a hard stop that they have to get to? If you do, maybe just give me a thumbs up or put a note in the chat. Great, if you could monitor that chat for me, I'd appreciate
Yes,
that. But
I will.
okay. So one of the values of Ptm App, depending on how well versed you are in GIS, is what I'm going to show you, you can do on your desktop. The idea behind Ptm App Web was that a lot of the functionality that you need to do your daily business, you could do on the website itself. So one of the things you'll notice when you sign in is you should come to a screen that looks like what I have here, is called a dashboard. It's simply a very quick introduction to the data sets that are available in Ptm App. And if you move your cursor over onto select Watershed, you'll see this little pull down arrow here on the screen. And if you click on that, you can see all the data that's currently available in Ptm App Web North Dakota. And to select a given data set, if you want to select the data set for your area, you simply toggle down and click on it. So I am going to go down to Western Wild Rice. You'll see that I move the cursor, it turns blue. And then if I press the button, it'll actually zoom to that watershed. So basically what I've done now is select a given watershed that I want to start working in. You can also do this step in other parts of the application, so you don't always have to do this in the dashboard. You can do this in the interactive map, which is what we're going to go to next. Once you make the selection, it gives you some information about who created the data and who to call if you have trouble. And usually it says GRIT in North Dakota. And then you get some very high level statistics about how large is the drainage area, how many different locations are in the application, how many catchments there are, and then some information about yields, sediment, phosphorus, and nitrogen yield. So what are the pounds per acre per year or tons per acre per year estimated over the whole watershed? There's a couple things that I want to point out related to terminology. You're going to see time and again this notion of priority resource locations. And those will appear when we get to the interactive map as just a red dot on the screen. Those are locations that when the data were created, GRIT entered into the desktop application. You can think of those areas as areas where you're able to retrieve information about how much sediment or nutrients are delivered to that particular location. Typically, those locations are monitoring locations, they're water quality monitoring stations, they're gauge stations, they're 12-digit HUC outlets or 10-digit HUC outlets. There's something of significance or important in that watershed. Then the other language you're going to hear is catchments. And I'm not so fond of that particular term, but that's kind of what we ended up with. You can just think of the catchments as really small sub-watersheds. And typically they're anywhere from, I don't know, 10 acres up to 40 acres, sometimes bigger. But they're localized drainage flow paths or drainage areas in the watershed, essentially. So that's the term we use. If now, once you've selected and you guys can select whatever watershed you want. You don't have to select Western Wild Rice. You can select whatever you want. If you now click, if you notice in the blue panel along the top here, as I move the cursor along, the different little icons change to gray. That basically means you're ready to select. If you just move the hand over to the interactive map and then left click your mouse on the interactive map, we're going to get a map up on the screen. And again, the idea here is I'm going to use the information in the interactive map to describe my watershed. You can print these maps, you can save these maps. I've even used this before when I've been demonstrating something in front of a board member. It works well for that as well. first thing you see on the screen is you see all those red dots with numbers. Those are the priority resource locations. So again, those are locations that represent where you can get information about how much sediment or phosphorus or nitrogen from the upstream area gets transported to those locations. Sometimes those locations are specific lakes or other water bodies that you want to work on. One of the downsides with the website, I think right now, is we don't call them something common sense. They're a number, right? So maybe you're used to working at a given location or a given lake. It doesn't show up like that on the screen. As we go through the workshops, when we do demonstrations, we'll tell you which points to use as part of the case studies. So it has simple navigation features. You can actually collapse this menu over here if you want by clicking on the double arrow, and it'll go away, and then you can expand it again by clicking on it again. And you can zoom in and out with the plus and minus here. Another nice thing for zooming, nice trick that you can do is if you push your shift key down and then you simultaneously push the left mouse button down, you'll see that I draw a box. And then when I let go, the application will zoom into that area. So that's kind of a nice feature. You can move around simply by left clicking and then dragging. So if you left click and drag, it'll actually drag the map across your screen to a different area if you want to do that. And then the other thing, if you want to change the base layer, which is kind of nice if you're working on a field, if you click on the way the expandable menus work over here in the gray, if you click on it, it'll expand it open. If you click on it again, it'll contract it so you don't see it. But you can click on the base map. If you wanted to do aerial imagery, you can go down and select the aerial image, and then you'll see that it shows up on the screen. So the aerial imagery is really nice when you're kind of working more as you zoom into the field scale. You know, if you want to get specific information about, you know, look at a field, you can see here, you know, the irrigation patterns on the aerial image that I brought up. Okay. So I'm going to pause there just for a few minutes. Does anyone have any questions before I go on about what I've shown you so far? And we're going to use the interactive map now for probably the next couple, 3 workshops as we move into doing the source assessment. Okay, so no questions? Everybody good? All right, so the next thing I want you to do is to click on the Layers tab, and you'll see that that expands open. And as you guys are using this application, write down things you like or don't like. You know, we'll try to get some of the things that are problematic fixed, you know, that don't make common sense. Some of this is a little bit challenging to use. So the way the interactive map generally works in terms of the layers, you'll see this little eye icon here, selection icon. If you click on that, it turns that layer on and off. So if you just click on your boundary, you can see my watershed boundary goes away. Okay. So that was one of the things for describing my watershed. What's the actual boundary of the area that I'm going to work? Next, what I'd like you to do is to go up on the priority resource and catchments and click on the little side triangle. Do you see that on your screen? So if you click on that, it expands the menu. Shows you the layers that are available for that particular category. Everybody with me? So one thing that I mentioned just a few seconds ago is about the catchments. Go ahead and click on the catchments. Those are the very fine drainage patterns that are available in Ptm App. These are a result of the hydro conditioning that Grit did when she did the data set. If you want, you can, again, zoom into an area. If you hit Shift, left mouse, and then pull, you'll see on my screen how I have a blue box showing up. That's the area I'm going to zoom to. When I let go of them at the same time, it zooms into that area. So what you're seeing is the very fine field scale, little teeny watersheds, if you wish, on the screen. That's the scale that much of the Ptm App data is represented. So when you think about what's my tons per acre per year of Sediment say you can retrieve that kind of information for this spatial scale. It's very fine. Okay, so those are the catchments. All right, a couple things more related to describing my watershed. If you toggle down, you can move through the interactive map with a slide bar here. Do you see how I'm doing that with my mouse? If you just left click on the slide bar, you can pull it up and down. All right. And a couple of things I want to point out. There's a variety of other layers that you can add into here to help you as you're describing your watershed. Again, when I say describe my watershed, I'm trying to get a sense of how it works. You know, what's the water flow pattern? Where does it go? Where are my lakes? Where are my rivers? What's the land use? All of that kinds of things. Some of those factors that we already talked about today. So it's 2 o'clock. Everybody good to go, like another 10 minutes at most? Yeah, okay. So the next thing I want to point out are these two layers here, support layers and state layers.
Mark, I got a question real quick.
Yeah.
Say when you click on that little catchment and it says sediment delivered to the catchment, is that what's being brought into that catchment, or is that going to the field edge of the catchment?
That's going to the field edge. So what Dustin's talking about is most of the information you can get additional details by simply clicking on it. So on my screen, I have the catchments displayed. And if I just left click on one of those, you'll see a box that pops up. Did you see that?
Mm-hmm.
So there's data associated with that feature. And this is true for the interactive map as well. For those red locations, those priority resource points, for most anything. When we get a little further, we'll be showing you how to display some of the conservation practice opportunities in the watershed. Functionality is the same. If you click on it, you get information about it. So what I'm showing you here essentially is a series of boxes that is associated with this particular catchment. And typically the kind of information is the size, how big is it, information about water, what's the runoff volume or the peak flow rate off of that particular area. And then as Dustin was asking, what are these numbers here, the sediment delivery to the catchment? This is the amount of sediment that actually makes it to the pour point, to the outlet essentially of that small sub-watershed that we're looking at. Okay, and usually it's presented both in absolute numbers like tons per year or pounds per year, but then what I use a lot also, it's also available as like pounds per acre or tons per acre per year. So you can get it both in terms of the absolute number, the totals, but you can also get it in terms of pounds per acre per year. So when I'm thinking about describing a watershed, I tend to use the aerial information more often, the pounds per acre per year or the tons per acre per year, because that normalizes the total amount by watershed size. Does that make sense to everyone? That's usually how I look at it, and we'll come to that in a little bit. But so clicking on it in the interactive map, you can pretty much get more information than you probably want. Any other questions before we keep going? Okay, so if you just expand the support layers, it'll show you other information that's available to you. Typically under the support layers, it's PTM, the way to think of it is it's data that Ptm App's going to give you. If you click on the state layers, it's just general information to enhance your map. So maybe it's easier to click on the state layers first and expand that. But earlier I said, you know, if you're confined to working in one county, you can turn the county layers on. So the way to do that, you notice when I put my hand over the state layers, it says turn layer on off. If I click on it, then anything I click from there on in will turn on the screen. Now some of these are scale dependent. So if you're zoomed way out, you won't see them until you zoom in to a certain level. But land cover was one of the factors that we said, you know, influences water quality. So you're describing your watershed, you want to know what the current land use is. You simply click on the land cover icon, and then it turns on and displays in the map. So you can see land cover data. One thing that I typically like to do is I want to know where the water comes from and where the water goes. So often I'll turn on my lakes and my rivers and stream layers because I want to see the flow paths. And again, if you want to get rid of that thing, you can simply click on the legend expand collapse button and your legend will go away. When you expand it, then you can see what you've turned on the screen, okay? So typically when I'm thinking about the watershed, I'm trying to understand water movement. That's what I do. And then all of your HUC layers are in here too. So I used when we did this, we used the USGS naming convention, but your sub-watershed are your 12-digit HUC boundaries. So if Bob Flath is listening, you know, you can get to your 12-digit HUC boundaries here as well. I typically don't like to leave the catchment layer on when I'm doing this step because there's so much detail there, right? One other feature I think that's kind of interesting that I'll show you again, you can turn on any of these you want.
Can we change the color of the?
No, you cannot change the color. You can change transparency on it.
Okay, because that sub-watershed one is like a green, and if you're using the scale one, I mean, you can't really see it a whole lot.
Yeah, that's true.
So I don't know if we want to make that like if you guys can make it maybe a darker colored.
Yeah, we can.
I don't know.
Those are the kind of good comments. So you can see it's kind of getting lost in the aerial imagery. If I change my base map back to topo, you can see them right here, right? These are your 12-digit HUC boundaries. But when I have the imagery on, I lose them. It's a good comment. Okay. So then just a couple more things for today that I wanted to show you are what's in the support layer, specifically as it relates to describing your watershed. And again, you can think of what's in the support layer as data that's coming from mostly from Ptm App, essentially all from Ptm App. One thing that if you really want to get detailed information about your water flow paths, you can turn on the water course lines. And so what you see are blue and purple lines, different lines of different color that come up. This actually is attributed by the size of the drainage area. So the color of the line represents the size of the drainage area to that point. These data are coming from Ptm App. They're the very detailed flow paths. And what I think they're useful in is more at the field scale. Like say you're working with a farmer or something and you want to have a discussion with the farmer about what's going on their particular property, you can show them these fine detailed flow paths that represents water movement. Now you might find errors in these, right? Because it's the computer defining those based on some various algorithms. But you know, here it looks like it pretty much represents quite well the flow direction. You can actually see the land use that this flow line is right down the middle of that swale. Okay. Couple other things before we knock off for today. There's a layer in here called Ptm App Lakes. Those are storage areas where we have estimates of the amount of sediment and nutrient that reaches those areas and then stays within them and what portion moves downstream. There's typically not a lot of those in a watershed. I can maybe find one here. Let me zoom out. I'm going to turn off my lakes layer. So this must be one right here. And so the nice thing, again, these are areas that are included in the desktop version of Ptm App when it was run. And so the neat thing about this, I think, you'll notice it corresponds with a resource point, this outlet number 71. But you can get estimates of how big it is, its volume, how much sediment and phosphorus reach the lake and how much leaves the lake. So here you have all kinds of information about that particular storage area. What's the estimate of the amount of sediment that it retains that reaches it? How much phosphorus does it retain? This doesn't retain much, so it's obviously a very shallow lake. The water moves through it very quickly. But you can also get current load estimates. So as we move down the road and we start talking about setting goals for restoration or protection of these water bodies, you can get information about how much sediment or phosphorus is actually reaching those water bodies. You okay, Matt? You good? All right. One more thing. And again, you guys can play with this offline when we're done. I was going to zoom back into a field here area. And the one thing I want to stress is that the information in here, it's not just for water quality planning. As we move through this, you'll find that there's tools in here to help you engage landowners about discussions on conservation, which was one of the outcomes that many of you or some of you identified that you wanted. And so one of the things that you can do in Ptm App is you can get estimates of sediment loss, both leaving the landscape and delivered to that catchment boundary. So what I've turned on here under support layers, I've clicked on sediment mass leaving the landscape. And you can see the different colors. Color scheme isn't fantastic, but essentially we have very low to high. We used to have the ability to control this symbology, which was better, but essentially the darker or the lighter brown the areas, the lighter the colors, the blues, those are areas of high soil loss. And where this is coming from is the universal soil loss equation. That's part of the prioritized target measure application. And the calculation is performed at the raster scale at a very fine scale, essentially whatever the grid size is. This is probably a
5 meter.
5 meter, okay.
It's a 5 meter.
So for each 25 square meter chunk of field, we're having an estimate of the soil loss that's leaving, that's being mobilized. So the value here is that if you had a producer that walked in and, you know, you want to engage them in a discussion about soil loss or conservation opportunities, this is the type of information that you could use. We had a question earlier. You can actually, again, you can decrease the transparency of this level of the, oops, sorry. So you can start to see the map come through as well, a little bit anyway. So this is information that might be useful to you when you're having discussions with a landowner. If you're, these same data you can get on the desktop, if you're using them on the desktop, here's the advantage of the desktop is the color schemes and how you represent that, you can control that. You can change transparency, you can change what you see. So just remember that. And to actually create this on the desktop, there is help. We can come back to this later, but there are actual examples that give you step-by-step instructions for creating these products. This product I'm showing you right here on the desktop as well. And again, the value on the desktop is, I'll go back to the old days of the highly erodible lands value. Like say you have a threshold, you want to know what parts of the field exceed that threshold or under it, you could symbolize your layers then to reflect that. Okay. So that's the introduction to using Ptm App to describe your watershed. So as far as I plan to go today, what I would encourage you is to, you know, before the next workshop, actually write down some of your questions, play with this a little bit. How many of you have played with this before or looked at this before? Dustin, Matt, okay, a few of you. So go ahead and break it, try to break it, play with it, use it. You know, again, within the context of how do I use this to describe my watershed? You can, by the way, you can print down here. So like say you generated a map and you wanted to put that into a report, you can print that out and save it. And that's useful like for the planning process in describing your watershed. So you can export that and save that as well. But try this out before the next go round. And we're going to continue to use this as a tool as we move forward. Okay, so one thing you can do as well, if you want, before the next workshop, is to actually select a point when you're using the interactive map. This is going to move into the next topic of using the sediment yield and phosphorus yield information to generate source assessments for your watershed. But just play around with it before the next session. Okay, any questions so far?
I just have another one on the web app there. So like, you know, I work with Spiritwood Lake, so I just clicked on it, right? Because I got the lakes and rivers turned on or whatever.
Yep.
And the water course lines and all that, or the Ptm App Lakes, and it shows me a depth of 12 feet in Spiritwood. Like, it's actually 55 is the deepest.
Yeah, that's the mean depth.
Okay.
Yeah, it's a mean depth. It's not a maximum depth.
Okay.
Yeah.
Just wanted to make sure.
Yeah. Those numbers, by the way, came from, you know, there's error in those. There's going to be error in those numbers. So the way we came up with like the surface areas and the mean depths and such in Ptm app is we had to fit like a regression equation to regional water bodies. So you're going to see that in times those aren't going to be perfectly correct. The way those numbers are used in Ptm app is they're being used to estimate the amount of phosphorus and nitrogen and sediment that's retained in the lake. So you just have to kind of be careful, right? I mean, you might have better numbers based on an actual topographic survey or whatever. Any other thoughts, questions? Okay, so I do have one more poll for you, which I think is just the workshop summary that I'm going to go ahead and activate. And again, you can do this on your own. It should be up on the screen. I've changed the questions a little bit. Really, you know, what I'm looking for from you guys, I don't have a cookbook on doing these workshops. So your feedback is very important. And to me, what's critically important is some of the tools that we're going to start showing you, even that we did today. Are the maps useful? Next week, we're going to show you like a little framework for trying to identify and prioritize where the water quality problems are in my watershed. Getting feedback, does that help? Is that helpful for me to decide where to begin my work? That's the kind of feedback that's super critical, because some of what we're doing is new. I mean, we're developing some of these tools and some of this information as we go. So, by the way, I have posted the last survey results on the Google Drive as well, so you guys can see those if you want. I did anonymize them. I took the names off of them just because, I mean, I wasn't personally concerned about it, but. All right. Well, we should get the technology stuff squared away by the next meeting because I'm not going to do it.
We should do it right now.
Any passing final thoughts from anybody? So the workshop next week, we're going to dive into like using our water quality data to identify problem areas in the watershed. And then we're going to start talking about, once we identify where there's a problem area, how do we combine the Ptm app data with it to decide where my priorities are inside of that watershed to begin my work. That's what we're going to focus on next week. And that one I may break up into 2 sessions, just kind of depending. there's quite a bit of content, so. And then from there, once we kind of get to that point, then we're going to start progressing into source assessment. How do we do the source assessment? How do we identify hotspots? And then we're going to move into setting goals. Is the Google Drive working for everyone? Good. Well, we made it even after the technological challenges. All I got for today.
Thanks, Mark.
Yeah, thanks you guys.
Thanks, everyone.
Have a good week and we'll see you next week. And by the way, if something comes up, if you have a question,